Okay, this is a coffee cup calorimetry problem, as you can read. What we're doing is putting 1.6 grams of a salt, ammonium nitrate, into water in a coffee cup calorimeter, and the temperature is dropping from 25 to 23.3 degrees Celsius. The first thing we're asked to do is write out the balanced equation for the reaction, calculate, and then the second part is going to be calculate the heated solution, kilojoules per mole of ammonium nitrate. So really simply for one of these, all that's happening is we have solid ammonium nitrate, so you have to remember that NH4 plus is ammonium, and NO3 minus is nitrate, so we have an ionic salt, and when we put it in water, it's going to just dissociate into its ions, into ammonium and nitrate, and both of these are going to be therefore labeled as aqueous. Alright, so part 1 done. Next part, on to figure out the heat of solution in kilojoules per mole of ammonium nitrate. So first thing we have to do is we have to look at the fact that we're dealing with a Q of reaction, so the heat of the reaction is going to be equal to negative heat from the calorimeter. Okay, remember this is sort of a general fundamental thing. When you have heat of the reaction, whatever it does, the opposite, it's either absorbing the heat from the water of the calorimeter or it's going to release it to it. So one goes up, one goes down, so to set them equal we need to make one side negative. Q of reaction we know is the delta H times the moles, and the Q of the calorimeter is going to be equal to negative again, and any change in heat of sign, ms delta T. Alright, so let's fill in the parts. Well, I guess what we're looking for here is a delta H of reaction, so we could also just solve this really quickly. So we're going to look for negative ms delta T over N, over the moles. So now what we need to do is plug in the various things. Now, the mass is simply going to be equal to the total mass of that calorimeter, but keep in mind that the mass of the calorimeter is the 75.0 grams of water plus the now 1.6 grams of salt that we've added, right? Because the overall mass of that solution will be those two together, so that's going to be 76.6 grams. Specific heat, unless we're given something otherwise, we assume that it's the same as water. Joules per gram, 4.18 joules per gram degree Celsius, and that holds pretty true for most low concentrations of things. It tends to fall apart when you get to a little bit warmer temp. And then the delta T, right, it's going to be the final temperature minus the initial, so in this case it'll be 23.34 minus 25, and that, if you do that out, we can see it's going to be negative 1.66 degrees C. Now that negative part is going to help us out here because that's what's going to let us keep track of whether it's exo or endothermic. Okay, and now we have to divide by the moles, and for the moles, like we've been doing all year, all we have to do is take the 1.60 grams and convert that to moles. So 1 mole, and the molar mass of ammonium nitrate is 80.04 grams per mole. So we get out of that 0.0200 moles. So we're going to divide by 0.0200 moles. And out of all this, the negatives cancel, and now what we get is we get a value of positive 26,576 joules per mole. Now we're going to need to go ahead and adjust this a little bit because first off we have sig fig problems, and secondly it doesn't really make sense to display it in joules when one, we're asked for kilojoules per mole, but also, as you can see, it's a more sensical value here because we have so many joules. So when we convert this to kilojoules, simply divide by 1,000. So what we're going to come down to is 26.6 kilojoules per mole. And that's our answer for the delta H of solution.